Good morning, ladies and gentlemen, and welcome to the main session of the Smart Manufacturing track at EBDVF 2021. This session is organized by the Smart Manufacturing Industry Group in the Big Data Value Association. This group is chaired by myself, Davide Dalle Carbonare, Business Developer at Engineering, and Sergio Gusmeroli, Research Coordinator at Politecnico di Milano.
Good morning, everybody, from my side.
Manufacturing, but industry in general, is definitely one of the most relevant key drivers in the European economy. Currently, what we are facing is not only an economic transition, but also a societal transition that take into the central place the well-being of the workers in the production processes. These aspects, identified as Industry 5.0, and their relation with Industry 4.0 are the topics under discussion today, analyzed through the lens of AI and data technologies. Today, we have a quite simple agenda. We have a session organized in two parts. The first one, 1 hour roughly, with a panel of high-level speakers, and a second part with a selection of H2020 projects working on the topics. We move now straight forward to the main part, to the first part that is moderated by Sergio Gusmeroli, and then we welcome directly on the stage, one after the other, our speakers for their introductory statements, and then Sergio will have some questions to them. So I welcome Martin on stage. I stop sharing now. You can share now your slides.
Yeah, just a moment, please.
Sure.
Wait, this is the wrong one. So would you see the slides?
Not yet.
Not yet? Okay.
Not yet, still.
I have
The
to
black
do it again.
screen, unfortunately.
Now it's okay. Do you see it now?
Okay, perfectly.
Yeah. Okay, so thanks a lot. First of all, many thanks for this honorable invitation. I just have to start my video. I have to start my video, so sorry. I tried to do that.
Okay, try to share again, maybe.
Yeah.
No problem.
Sorry for this problems I have here. This is caused by the No, I have problems with the sharing, sorry. Sorry, it seems not work.
Okay.
I think we have to find a different solution.
Just keep it the way it is, in case. Just reduce the left side for.
Yeah, but this doesn't really work. Sorry. Does it work now?
No.
Unfortunately not.
Sina, can you?
Now it should work.
Okay. Okay.
No, it's okay.
Whew, sorry for this.
The
this
floor is
mishap.
yours. No problem.
Okay, so thank you very much for this honorable invitation. So I will use my 7 minutes now for giving an introduction into Industry 5.0. It's a relatively new concept. It's a still disputed concept, but the ingredients of this concept are known for quite some long time. Let me start with the digitalization. Digitalization changes the world for us all. Yeah? So it has an impact on all sectors of the economy. It has an impact on the whole society and of course also on industry. It accelerates the production processes, it makes it more flexible, and it has enormous potential to increase the efficiency and the productivity. And I would say this is in a nutshell or in the core what the Industry 4.0 is about. So the use of digital technologies, digital connectivity together with other enabling technologies, the Internet of Things, ubiquitous sensors, and so on to create this, what Klaus Schwab called the cyber physical space, with the primary target of increasing efficiency and productivity. The thing is, the Industry 4.0 holds a huge potential also to improve other things like sustainability by, for example, improving the material efficiency or the energy efficiency, or by improving the work-life balance of workers due to more flexibility. So there is a huge potential also for other benefits in Industry 4.0. The thing is, this is not automatically happening. There is not a sort of trickle-down effect if we increase the productivity and the efficiency, that it will immediately lead to more well-being of the worker, for example. Let's make a side step to the priorities of the European Commission to illustrate this a little bit better. They were formulated in 2019, and there are 6 of them, and I just want to draw your attention to these 3 which are in this box. The one is digitalization, I already mentioned that. The other one is the Green Deal, so the transformation to more sustainable system. And the third one is an economy that works for people. So that means the clear goal to put humans in the center of what we do, to have positive benefits of this huge transformation we are undergoing for all Europeans, or at least for the majority of Europeans. However, since 2019, there was another major event which put our attention back to a question we have been discussing for many years, and that is the question, how resilient is the European economy? Remember the ship which blocked the Suez Canal? This caused repercussions for months in global value chains. Or remember the recent reduction in the economic forecast for major European economies due to the semiconductor shortage, which was caused partially by disruptions induced in the production sites in Asia due to COVID. So the European economy is far from being resilient. So what we need is an economic system, or to be more narrow, industrial system, which is resilient, which is sustainable, which focuses on human beings, so puts the human in the center, and which uses all the tremendous possibilities of digital technologies to achieve that. And this is in essence what Industry 5.0 is about. So Industry 5.0 is a sustainable system which respects planetary boundaries. It's a resilient system which allows to adapt to unforeseen changes, and it puts the human in the center, and it empowers people. So it understands technology as a mean to enable or facilitate the work of people, to make it that they are able to do it with less effort, with more precision, and also with more satisfaction. And all that means, of course, that Industry 4.0 and all these digital innovations are part of that. We cannot do without that. It's simply a broader scope. It's also worth noting that Industry 5.0 gives a more prominent role to industry. Industry always has been the backbone of the European economy, provider of jobs and growth. But it would be more than that. Now, in this system, it would be a resilient provider of prosperity. So it would respect the planetary boundaries, and it would be human-centered. of course, after all these high-flying words, what usually the question which is usually provoked by this is, but why on earth should companies do that? So companies have to make profit to survive. They have to stay competitive. There must be a business case. So what is the business case for Industry 5.0? Well, the answer is it would be a misconception to see resilience, sustainability, human centricity as a barrier to competitiveness. To the contrary, at least in the midterm, it will be an asset. Unfortunately, I cannot go into detail here, but we have factual evidence for that. And I just would like to show you one example when it comes about attracting the best talents. There are studies which make clear that 3/4 of millennials said they would take a pay cut to work for a socially responsible company. So when it comes to attract the best talents, if you have a social responsible profile as a company, you have a competitive edge and you are in a better competitive position. This is just a small example. There are others as well. Let me finish by emphasizing that we do not start from scratch. Industry 4.0, but also Industry 5.0 related projects have been all over our research and innovation programs, starting from FP7 over Horizon Europe, and now in our new program, Horizon Europe. This is once again one of our focal areas. I have here 3 examples of Horizon 2020 projects, which focus on Industry 5.0 related measures. I have learned that we will have another 3 presentations at the end of the session of Horizon 2020 projects, which also show what they can, how they can contribute to that. And we are currently preparing the work program for Horizon Europe for the work for the years 23 and 24. And of course, again, this will be in the focus of one of the focal areas which we would cover. If you want to learn more about that, I have here a link where you can download and read our concept of Industry 5.0 and other useful documents and information. Thanks for your attention, and sorry for my difficulties at the beginning.
No problem at all for the initial troubles. Thank you very much for your pitch and for very nicely introducing the concept of today. I now invite your colleague from DigiConnect, Matthias Kuhn, to join us on the stage and to share the screen.
Yes.
Thank you very much. Good morning,
everybody.
The floor is yours.
Thanks, David. And welcome from my side. I'm from DigiConnect. Yeah, in the beginning, I would like to state that I still stick to the concept of Industry 4.0 because for me, it also includes human centricity, sustainability, and resilience. But maybe we can discuss this later because now I want to talk about manufacturing and data as an enabler, because that's the topic that we want to address. And we already have published a data strategy, and you know also the statements of our commissioner that it's important that every company in Europe makes the most out of data. And this can be used then for resilient topics, for sustainability topics, and for us, it's important that we leverage the momentum that we see currently in all this data sharing concepts. We already have lots of experiences how we use data within a company, and we are now at the verge of this data spaces that make data sharing across companies more valuable and better manageable. And we wanted to support this development with our Digital Euro program, which is a program that's not such so much research oriented as Horizon Europe and more deployment oriented. Therefore, we really want to address these initiatives that are already happening and want to leverage them to a European level. And we want to do this for different sectors. And one of these sectors, we call them industrial or the manufacturing data space. So no matter if it's 4 or 5.0, here we really want to see how these data spaces can be developed, not only as a technical infrastructure, but also as a soft infrastructure with all the regulations and agreements necessary to really build trust among the different actors in such a data space. And we have now opened already some calls in the Digital Europe program to prepare this with some support actions that we want to see in the first place, where the idea is to bring the stakeholders together to define the necessary governance structures and architectural frameworks. And here you can see the current call that I want to highlight. This is the call for the coordination and support action for the manufacturing data space, where the deadline is the 22nd of February. And as I said, the idea is here to really see what's already happening in this area, and then to develop priorities together with the stakeholders before we then already in the third call of the Digital Europe program, we'll have really a deployment call. This means when the support action starts, the stakeholders already have to prepare for this deployment call, in which we went then to deploy 2 data spaces. We talk of different data spaces because we think it's important to start small, to start with a very specific use case, very specific topic, and for this topic then develop these data sharing models before we then integrate these different data spaces in the more overarching industrial data space. And besides the application-oriented aspects, we also want to already address some horizontal aspects that support the twin transition. So already from the beginning, we think it's important to see how these data spaces can support also reporting of maybe some sustainability measures and regulations, like, for example, the digital product passport. Here we see it's necessary to help all the participants of a data ecosystem to really reduce the costs that may arise from such regulatory compliance by making it easy to use the data that you have already collected for other purposes, then also to make them available maybe in an aggregated form for such reportings as we will have on CO2 footprints and so on. And with this, we think these manufacturing data spaces will also be good support for what we call the twin transition. And we then also want to see what are the commonalities between these different data spaces that I have shown in the second slide. And therefore we have a data space support center, and this support center will then mainly address the connections between these different data spaces and also the connection to the underlying infrastructure, which we will develop with help of the European Cloud Data and Edge Consortium. And here you can see that we also already had some info days on the calls. We also have 2 more info days already announced for, on the one hand, the smart cities data space, on the other hand, for the health data space. So if you're not only interested in manufacturing, have a look. If you're interested mainly in manufacturing, the results of the manufacturing data spaces info day are already available on the web, and you can see what we have as recommendations to apply for that. And with that, I am now on my 6 minutes and leave some time for discussion, and really looking forward to that. Thank you.
Thank you very much, Matthias. Thank you very much. And now, thank you both for the perspective from the Commission. Now we move to the association side. We welcome Chris de Coubert from EFRA. Please, Chris, start sharing your screen, and the floor is yours.
Thanks a lot, David. Thanks a lot, colleagues, for having me at this session. So, yes, Industry 5.0 opportunities and future scenarios. Maybe some context. Well, I've noticed also in the interventions there seems to be some discussion about what the brand 5.0 means in terms of what Industry 4.0 stands for. Clearly, for me, what I see is sustainability, human-centric approaches, resilience in European industry, the targets, and it's the targets that matter. That's what we are discussing now. I've seen in the Industry 4.0 vision that sustainability and the role of humans is very important. What I take definitely from the merit from Industry 4.0 is the importance of the connectivity, the use of data, the IoT for the purpose of optimization. And optimization can mean a lot of things, and definitely the role of these technologies in terms of making the role of humans in factories very significant, and the skill factor to support the teaching factories and all these different paradigms that are hugely important. The role for sustainability, for energy efficiency across a factory floor, but across a value network as well. The relevance of interoperability for circular economy. All this is key. So I believe we're going hand in hand in reaching the targets for resilience, sustainability, the role of humans, and the deployment of all these technologies. And I'm putting up this slide here that shows actually the storyline of the multi-annual roadmaps, strategic research agendas that we, from the AFRA point of view, the AFRA European Factories of the Future Research Association perspective, did develop for the implementation of the partnerships, which is now transforming into the Made in Europe partnership. That actually these concepts were very important from the start. And well, as already also mentioned by the colleagues of the European Commission, we are continuing this effort. And this is a framework actually of the Made in Europe partnership. And clearly we see there these targets on the left side: European Fit for the Digital Age, economy that works for people, SMEs, European Green Deal. Definitely, of course, the excellence part is very key to competitiveness. The point of this initiative, and for many initiatives, but definitely in the context of manufacturing, is pull the whole key enablers sets at the service of these targets. So, and I think that's the strength of what we're doing with these partnerships, to really bring together all these key competences, whether it's key competences in material processing, or IoT, or data analytics, or data spaces, and human competences, including social sciences, is to pull this all together for the benefit of having a big impact. So I believe this is definitely something that, as a partnership, we aim to support in cooperation with the different initiatives that really are driving this, be it more the technology enabler side or the impact side. Okay, this is a slide actually I used in a previous session in this the data forum, and it relates to what we refer to as a pathway, where you go from a less advanced situation in terms of digitalization to a higher level of use of digital technologies, and AI and data is a key role in it. Well, AI, you don't do AI with proper relevant data, with quality data. And you need, in order to implement this storyline, to go from the lower level of digitalization to the higher level of digitalization, you have to address a lot of key enablers, and the skills is a key one in it. And now, whether this is for environmental sustainability or actually human robot cooperation, still the key is that humans are a part of this transition, and change management, the involvement of operators, the involvement of higher management in this storyline is key. So I think that's also what we're aiming for in the context of this initiative. It was referred to by the previous speakers as well. There's a lot of examples from Factories of the Future partnership. I think of projects like with the names Inclusive, Factory to Fit, Shop for CF, Satisfactory, HR recycler that actually already by the name show how the two or the different components in terms of human sustainability, resilience, the social aspects are being merged into one project in many cases. So we're definitely building on that. Actually, this is high on our agenda. We are organizing stakeholders meetings, public stakeholders meetings. One happened last week. Another one will happen next week on the 9th of December. And actually the topic, the theme of that stakeholders meeting is circular environmental sustainability and human-centered in manufacturing. So we're actually straight on the topic, and we're happy also to welcome you there. So thanks for your attention.
Thank you very much, Chris, for your different point of views here presented. Thank you very much. And now we stay, of course, in associations and representatives. I welcome Thomas Hahn here on stage. That is not only representing Big Data Value Association, but also Siemens, I would say. And Thomas, okay, I see your slides.
And you can hear me, and I can immediately take over. Many thanks, Davide, introducing me. Yes, I'm with Siemens, as you see, and internally, which is other company called The Fellow, taking care for IoT or IIoT Industry 4.0 aspects and AI for the technology inside the company. And on the other side, I'm active in different external roles, and today I'm speaking a little bit more about BDVA and as a member of the platform, of the German platform Industry 4.0, with this cooperation in Europe and outside Europe. And as you see here, and I ask also Davide and Sergio, can I make it a little bit provocative? And Chris mentioned this also before. You see in the title, I excluded the 5.0 and put it the 4.0 inside. The reason is quite simple. You know, when we're speaking about Industry 1.0, it was some kind of water, automation via water and so on. Then 2.0 was, you know, the assembly lines, electricity. 3.0 was around bringing automation, programming, logic, and controller, sensor actor stuff, you know, also this topic on the shop floor. And 4.0 is about smart production, smart services, including AI, including sustainability aspect, including assembly line, but always keeping in mind also what we are doing with the humans and how we are addressing the needs in the future working environment. So that's why a little bit more provocative, but I'm allowed to doing this in the title, but I will come later back. Now I would focus first of all in two examples very briefly about AI and data usage. Then I will go over to data spaces, and at the end I'm touching a little bit, but Chris has used a comparable slide, what is from the Industry 4.0 perspective, the vision. No, sorry. When you're speaking about about AI usage in manufacturing domain, I always like to use this overview slide and showing also the strengths where we in Europe or as Europeans in and for Europe can build on. So this we will see in the bottom the knowledge, how the systems are running, how we know how the different processes are running, how the machines are running. So the domain know-how, and to be honest, which we have keep also because it's a lot of the company, I'm not in this case speaking more about all the small and medium-sized enterprises, have a lot of knowledge where you can build on it. And we have to look how we bring this to the next level regarding data, AI usage. So we have on the one side, the perception part when you're looking above, collecting the data from the systems. Then you have the cognition side. You see in the middle, hopefully is visible, you have the classical control loop, maybe in PID controller, where you can extract data. Then you have maybe a reinforcement learning loop, machine learning, AI. And then you have the way to be on a controlled way to feedback maybe new parameters for the PID controller, controlled way, because you have not to disturb the running process, you have to improve them. So that's, let's say, roughly where a lot of projects are ongoing, running. I have later one example about this, why we are doing this. And big data value is not just by chance call big data value, because we want to create some impact, some value based on the data, based on the received data, based on the knowledge, to improve something, in this case here, existing processes. And now we're coming immediately to the two examples. One is here the Boost 4.0 project, where you see here in an assembly line, stamping line, how you can use with collecting data, using AI methods, improving competitive advantage, which you're seeing, improving, let's say, control time, quality, how many products have to go back because some defects are detected, or when you're detecting. So meaning a lot of possibilities which are at the moment ongoing, to use data, to use AI, to create impact, to get value out of the data with methods. In a controlled way, like expressed before, because in an industrial environment, you have to look, when you're using AI, you have also to look what's in the future. You have to respect the functional safety issues, because at the end, you have some kind of systems running. As meaning when you have in a private life, maybe in fault in looking at your private photos with AI methods, in the manufacturing, we have to be very, very careful, because you can also hurt people when something is running wrong. Meaning one aspect is really to improve with data and AI existing products, solutions, processes. And on the other side, maybe the more tricky part, also give us the opportunity to tap in new business opportunities. And here, I've given you an example about the Catena X project, where we're speaking about traceability. Traceability is on the one side, that we know which part is produced on in one series or the other series, and when it is produced, when you have a defect, and you have maybe in this case a callback activity for the car, so you make it very direct and precise. You have, but also you have the possibility, when you're looking at the moment at the problems to get the chips, the semiconductors, to improve the supply chain. The sustainability that's all around the CO2 footprint and so on, and only to give you the feeling. So we have the data AI is one possibility to improve existing projects or solution or products. And of course, we have also this opportunity to tap in new business opportunities, create new business models for us, and think about the first words that we really extend our knowledge and to be ready for the digitalization. Nobody can do this alone. We are doing this from an association perspective in BDVA in collaboration. You here in the bottom, you see here Gaia X, IDSA and BDVA, where we build some kind of data space business alliance really to provide together the basis. For sure, this is open, as it's not a closed shop, so we have open to other collaboration. Then we have the industrial AI stuff, where BDVA is, for example, looking forward what is in the AI Act included, how an industrial trusted AI can look like, how labels can look like, how we can also reflect the risk classes. And we do this as BDVA with an industrial AI perspective, but in collaboration, as you see here, with the AI research communities like Alice, Claire, or Euro AI, and to create impact in the different verticals. And here, Chris, for sure, I'm always missing EFRA, but I promise you next time EFRA will be also raised in this topic. This is, let's say, a little bit about why maybe they and also is not running this improvement with AI or to tap in new business opportunities without data spaces. Matthias mentioned this before, and this is all it gives you a feeling about database sorts in the Industry 4.0 domain, where you see on the left side some kind of value change, and exactly here must be some database supporting data spaces supporting this different value change or use cases from condition monitoring, manufacturing, supply chain traceability, and so on. And that is what we have covered here in some kind of reports where you have the link to this. I can make it short. and now we're coming briefly back also to a discussion about 4.0 or 5.0. And thanks, Chris, you've shown a similar slide. In 4.0, we are looking about autonomy, all this security, data topics, data space topic, to have trust in the data space, to have trust in the exchange of data, to keeping the control of your data, which is from a perspective of data spaces also covered from the GAIA-X association, for example. By the way, GAIA-X was also a spin-off of the Platform Industry 4.0 initiative. Then we have the interoperability stuff to get the data, to be connected, and the sustainability, also what is a working environment, education, what we can do with climate change and so on. This is where we are working on together, collaborative, as I have shown before. And the second issue where I'm a little bit careful and changing and brand, like Industry 4.0, besides the technology and aspects which I mentioned in the previous topic, this term Industry 4.0 we spread around the world. I know that Japan have an initiative called Society 5.0, but the 5 or the 4 is a numbering in Japan, like 13 in Germany, which is not so well accepted. But nevertheless, we let's say exported the term Industry 4.0 around the world. So I'm very careful not changing the terms now, because we are still in a complete move in establishing this. So last slide is coming back to the AI, and I mentioned this before, when we're using AI in an industrial environment. I mentioned before the functional safety topic. You have on the left side some kind of circumstances or preconditions about real-time resilience, reliability, and so on. Then you have the safety topic. You have here the regulation, legal aspects, functional safety, or say high-risk classes, and of course the demand what we're doing. Also meaning in the manufacturing domain, we are having in mind different aspects in usage of AI. So that's all from my side, only to give a very brief intro about my thoughts. Thanks a lot.
Thank you very much, Thomas. Thank you also for your statements. And now we move quickly to the last speaker that we have for introducing the panel. We move to Ales Ancic, representing the Slovenian factories of the future. Ales, please share your screen, and the stage is yours.
Thank you very much. Hello to everybody. Okay, I'm sharing my screen. Okay. Do you see my screen?
Yes, not in presentation mode, but
okay.
Oh.
So first of all, I would also like to thank you for the invitation. It is my honor to be here. Today, I'm going to present our SRIP Factors of the Future. SRIP, it stands for Strategic Research and Innovation Partnership, and it's one of the main initiatives from Slovenian government towards connecting companies, research association, and government facilities to get as quickly to the level of factors of the future to implement Industry 4.0 and to basically digitize the Slovenian production system. In scope of this work, we are doing very much to help the companies to get the latest research and get the latest advances into the industrial processing, and we help them through education, but also here at SRIP and of course at TECOS that is implementing this, we are really helping them, I would say, on the application level. So to do on-hand demands, what do they need? So what we want to do with them is basically helping our clients, helping our members getting the latest technology, getting their design, their products optimized, getting troubles, problems, and solve them, troubleshoot them, what they're doing wrong. And through, I would say, iteration, getting to get the best products possible as quickly as possible and of course, as cost effectively and energy possible to get them to the market, and to be a global partner, and to be a global player into today's market. So our agenda, our vision is not just to be, I would say, day-to-day solver for the companies.
Alex, sorry to interrupt you, but if you're browsing your slides, unfortunately, we still see the
first one.
Yes, the first one in edit mode, so we don't see the full screen.
Sure. Okay. Is this better now?
No.
I don't know why. I can try to share it again.
Yes, please.
Okay. Okay, so you see now the first slide?
Yes, now I see slide in full screen, so you can move on to where you stopped. Thank you.
Okay, so yeah, this is the second slide. So as I was saying, we are trying to help really on-site the problems the companies have. So with the implementation of latest technologies, with the implementation of Industry 4.0, with the implementation of the latest software and hardware, to try to help them to solve their problems and try to optimize their production, I would say, to the level of the Industry 4.0. So I would say we are very hands-on center and very hands-on organization that wants to help the companies, not only with implementing policies and being their representative in the government, but really try to help them in the daily troubles that they have in their production. So we don't want to be just, I would say, day-to-day problem solver. We don't just want to be to see as an association, but also as a long-term strategic partner to the companies in Slovenia, whether they are SMEs, whether they're large companies, and basically help them grow and help them develop new products and help them be one of the best players on the global market. So we are organized, I would say, into the 4 pillars that are very important for the companies. First, it's really engineering services. So the services where we try to help them find a solution they don't have the capabilities inside. So usually, especially the SMEs, they don't have the expert for the Industry 4.0. They don't have the experts for the digitalization. They don't have the expert for advanced software usage for virtualization of their products and so on. So we try to be as close to them with engineering services and implement quick solutions, whether they're just small troubles that they have with their products, or help them to optimize their production lines with robotics, with AI, with any kind of automatizations and process management systems. Of course, this is also going, it's in connection with also research. Usually companies, they need tailor-made solutions. So we try to help them through the research and try to research what kind of technologies are best for their companies and what kind of products they can implement with help of new technologies. Of course, having this knowledge, we go to the 4th pillar. This is how to transfer the knowledge to them. We do this with specialized trainings. We have year-long seminars on Industry 4.0, product development, optimization of the product, optimization of the product lines, and so on, and help them to get this knowledge that we have here and basically use it. And of course, at the end, we couldn't do that to be an association, a cluster, and to be the link between the companies, between the research centers, and of course between the government. So it's between the national government, but also between the EU. So to hear the companies, what do they need, and be their speaker in the government facilities in the EU and so on. Basically, why we are starting to do this, we started this because there's really high interest. It's from the SMEs, from the big companies. They really need support in prototyping, demonstration, testing, finding solutions. We have strategic partnership with other SRIPs and other DIGs, and we really want to develop also for them demo facilities. We want to include them in other partnerships as our ED, Interreg partnership, EFRA partnership, and similar. So we also established, beside the SRIP Factors of the Future, also DIH manufacturing, trying basically to digitize and implement the companies with the latest technologies in Industry 4.0, but also other fields as circular economy, green production, new materials, and so on. We are connecting Slovenian SMEs through the field of tool making, molding, processing, production, materials, as a plastic materials, as a metal material production, and similar. We help them create a national and international value chains. We also help them supporting quite funding. Usually, special SMEs, they don't have any kind of department for this, so they are really struggling to get funding, and also then getting through the process of implementing the research results and getting to the end of the project. We help them with testing, with prototyping, trainings, and basically trainings in new technologies and in existing and future experts. We are not implementing only Industry 4.0. We try to also implement, as I said, green technologies, life cycle assessment, the new materials, advanced multi-physics analysis, mechatronic systems, robotics, and of course also AI. We are on the market already, I would say, 27 years. We are the oldest Slovenian technological center, and basically we have a team of passionate experts that are doing this and helping companies really to get what they deserve, so the best services to get the best products. Any kind of questions, of course, we can discuss it later.
Okay, thank you very much for representing the Slovenian community here. And then now we go straight with Sergio to the questions for the panel. Here is the list of speakers that we had, and then I ask Sergio to jump in and start distributing questions to our speakers.
Okay, thank you so much, David, and thank you to the speakers. I think we really had a very interesting panelist, and there is one question from the audience, and Mr. Ken Forster, he said, "I'm surprised we say Industry 5.0 is not a revolution. The past 24 months have shown that the Industry 4.0 focus on efficiency is not enough. The promotion of people and planet to equal profit is new, needed, and revolutionary." Who wants to comment this briefly? Because I don't want to spend all the time of the panel discussing whether it is a real revolution or not. But
well, I could answer that, because this it's not a revolution comes from my slides. Huh? So it's not a revolution in the sense of the preceding 4 industrial revolutions, which were all big technological steps, like mechanization or not, electricity or not, computer or not. In this sense, it is not a 5th industrial revolution, but in the sense what Mr. Foster said, completely, as I would say, a reorientation of the purpose of the direction. It is a revolution. Yeah? But also to echo that, if for example, Industry 4.0 includes all these elements of Industry 5.0, then the question of how to label it is of secondary importance. However, I don't want to shy. I think there are good reasons to come up with a new label of Industry 5.0. But as I said, the most important thing is that we implement resilience, human centricity, and sustainability in a sober way, and then it's fine. Huh?
I totally agree. It's the targets that matter and not the label. Exactly. And for me, Industry 4.0 is not only about efficiency. The main idea was autonomy and to put things from a top-down more to the bottom-up approach. But let's skip to the other questions, Sergio.
Exactly.
Sergio, back to you.
Yeah. Okay. Thank you. Good. So I could maybe merge together question 2 and 3. So is there a European way to human-centric, sustainable, and resilient manufacturing? And basically, which is the difference of the European way to human-centric, sustainable, resilient manufacturing? I'm not using Industry 5.0 on purpose. And which are the pillars and the specific characteristic of Europe to address these 3 main challenges, which are, as the audience said, which are emphasized by the current COVID crisis.
Maybe I start in trying answering. First of all, I said it, I think before also, that we have in Europe, when you're speaking especially about manufacturing industries, we have a lot of knowledge, domain knowledge, which, you know, when you're looking around the world, we have not to be shy or other way around. We are in several areas, let's say, market leader, and we have to build on it. That's the first statement. Second issue is when we, and I think here we have also an agreement between all of us that we want to share and make it in a European way, let's phrase it in this way, not to repeat human-centric, sustainability, resilient, and so on. When we do it in a European way, this is also for us, now I'm speaking as a company, an advantage and competitive advantage when it's selling our products around the world and solutions. So meaning we have, besides the domain, also some kind of values where we can build on and extend. And to be honest, also I have several discussions, for example, with US, with a comparable initiative from US Manufacturing USA. And there I was very surprised because now speaking and looking at us in Europe, what we are doing and how we are doing this in a very keen, interested insight. You can make the same when you're going to the East. It was only one example. As a meaning, we can and should and must do some kind of European way because it's from advantage from us. And last but not least, the sustainability. And as you know, coming from Germany and with election, and when you're looking now in the contracts between the parties, you know, sustainability, this, or in our words, circular economy stuff, or however you describe this, we must address and we can address. That's only my thoughts on it. And again, here, advantage for us, competitive advantage.
Yes. May I add something? You know, the proof of the pudding is the eating, and in terms of political priorities, this means the budget. Huh? And if you look what are our big budgets, let's start with the big research and innovation programs. There you have a clear focus on what we call the green, so the twin transitions, so on the Green Deal, on the digitalization. If you look into the recovery and resilience package, there the member states are required to provide plans which have to fill certain criteria, also in terms of innovation, but also in contribution to digitalization and to contribution to the green partnership. So you see that the European level tries really to be coherent in that, and to put also the money where the mouth is. So I'm modestly confident that we will really achieve something by this way. And as Thomas correctly said, it's globally seen in the global competitiveness. It is already an advantage. If you look where is the European industry strong, then it's to a high degree also in the, I should say, in the green part of the economy, which is also a little bit due to a strict regulation here. So it pays off to focus on these areas, whatever level you may give it.
Yes, I fully support Martin and Thomas that we are already a thought leader in this green topic, I think, worldwide. But if we now talk about the resilience, I think that we also have a European approach when we address this resilience and sovereignty, not only by saying we have to be completely independent, but to better understand how we manage our supply chains by diversifying them and by this the already diversity we have in Europe, we are the best placed to have it also on a global scale, management of such diversified supply chains and not thinking about all made in one country.
Exactly.
Maybe I can complement that. I think the responsiveness as a characteristic of European manufacturing, be it on factory level or an ecosystem, is a key to resilience. And whether it's for a market demand changing or a disruption, or both that's stuck, or a pandemic, you need the technologies to cope with it, but you also need the people to then make the adjustments on the system in a complementary way. I think that's where our strength will be for the future. I think in terms of a legacy of the research community that has been looking into these aspects, there's really a great pool of competence that we can rely on and should rely on. So there I see that the European way, I think there's many people on the industrial side, on the research side, academic side, that are convinced that these technologies approaches can be pulled together. And I think indeed this, as Martin Hummer said, the point is of course to give direction also by funding, by having the right targets. What we see in Made in Europe, and maybe that's already maybe in anticipation of the reference to Made in Europe, is that we see the transition. We've seen already a lot of projects in the past, but we see, for instance, there was a column zero defect, zero waste. So the point of manufacturing zero defect, considering the fact that zero waste, the environmental aspect, is a very important one. We see that a lot in projects. And I believe this holistic approach is probably our strength.
Okay, very, very good. Passing now to the demand side, to the manufacturing SME. So we see that there should be a transition towards these three principles, and that there will be a European way to do this, which means that we will have actions in order to implement this transition. And my question is mostly to Alex, if there is a difference in his perspective to put in place these transition measures between big European countries and smaller European countries, and if there is a strong difference in these measures between large enterprises and SMEs.
Oh, thank you very much. Yes, there's the difference. Well, I don't know about large and small countries. I would say it's a difference between developed and undeveloped countries. I would say this is the main difference now in Europe. So it's I would say more Western countries. You can also see small countries like Belgium and Netherlands. They are very highly developed in the Industry 4.0 and Industry 5, implementing also Industry 5.0, and they are very on top of it. So I would say the difference is newcomers to the Europe. So from Eastern Bloc, so they're still catching up the most developed countries. And of course, there is a really big difference between large enterprises and SMEs. the difference is that large enterprises usually have their IT department, they have their digitalization department, processing department that really deals with this on everyday basis. So they have experts who know what are they doing. They are seeing what is going on the field, and they are implementing. It's their job to implement new developments, new achievements, and new, I would say, research discoveries to the production. So the problem with SMEs is they don't have such experts. So their lack of experts, there's lack of awareness of what digitalization means, what Industry 4.0 and 5.0 means. And they are struggling with day-to-day business. They're all usually overbooked already. They don't have enough manpower to do their regular jobs. So they're not seeing the big picture. Usually, we don't have to underestimate the SMEs. They know that there's a lot going on. They're implementing, but usually they're implementing partial solutions. So they're installing, let's say, robots. They're installing automatization. They're installing some kind of monitoring systems and similar, but they are doing partially on day-to-day basis. So on day-to-day problems, they're installing this solution. They rarely go with complete renovation of their production. So to help them to have the complete system of virtualization, of automatization, of robotization, and of course of complete management system of all the production facilities that they have. So this is the problem that you can see between small enterprises and the big enterprises. It's the step that they have to do. So the first step is to understand what digitalization and implementation of Industry 4.0, 5.0 means for them, to have this understanding, and then to have the courage to do it. So to have to decide that they will do it, so that they will change in, I would say, in basis of their production. And of course, at the end, when they want to do it, they don't have the capabilities to do it. They don't have the manpower, and they don't have the experts to do it inside. So all this has to be addressed also by European Union and also on the national level to help SMEs, which are really the backbone of any country, to help them to make this transition. So I would say this is the main difference between big enterprises and small enterprises. They're struggling. There's a huge amount of information outside. As you know, there's, I would say, weekly some kind of education on Industry 4.0, on the digitalization, automatization, and so on. But what do they really lack is really best case scenarios, light beacons, and examples, real-time examples from the industry, so they can see what kind of gains are they getting for their money, and what kind of achievements will they have, whether they go into this implementation. So they're really straightforward in this, and we also have to approach them very straightforward to convince them that they have to make this transition.
Thank you so much, Alex. Any more comment, Thomas?
Yeah, very briefly, Alex, you described this very, very well, and I said it always in this term. Smaller medium-sized have a lot of knowledge. They are the backbones. They are covering 80%, for example, or more than 80% in manufacturing domains in Germany of the GDP. Only to give you a number, when GDP for manufacturing is around 24% in Germany. That's a significant part, first of all. Second is, you're right, I said always a little bit, let's say, pragmatic. They cannot have a Thomas Hahn and taking care of these activities. This is the resources, what you mentioned. And last but not least, because, and now I'm speaking as a representative of a big company, it's our obligation to collaborate, to make it together. Because, you know, as a one side, they are our supplier or our customers, and we have to keep the complete system lively. And that is really, and I'm speaking again to us as a representative of a big company, to collaborate and to set up, let's say, needed action in doing this, to go together forward in this digitalization. Just only my comment on this, but 100% agreed what you said.
Thank you so much. Thank you also to all the panelists. As we said in the last sentences, we need concrete cases. We need the best practices, success stories. And this is the aim of the second part of this session, that we are going to show some concrete cases coming from the portfolio of our projects. And thanking again the panelists, I will give the floor to Davide back. Thank you
very much, Sergio. And thank you very much again. I list them back here, all the wonderful speakers that we have for the first part. Time is running, so we go straight to the second part, where we have this selection of H2020 projects. I invite Andrea Bettoni on the stage now to share the screen and to start explaining what they are doing around the content, around the context of Industry 5.0. Thank you. Andrea, I don't know if you're muted. I don't.
Thank you, Davide. Yes,
okay, now I hear you well.
Okay. Thank you again, and good morning to everyone. Today I'm going to talk about mutualistic and adaptive human-machine collaboration, which is one of the nuances of this Industry 5.0 paradigm that we're introducing. I'm Andrea Bettoni. I work at the University of Applied Sciences of Southern Switzerland. I've been working on this topic of human-centered smart production systems even before it was labeled as Industry 5.0. I'm now the coordinator of the Kit for SME project, and you will see in my presentation a few insights from what we're doing. When we started talking about this, this mutualism and this adaptive system, we were thinking mutualism in the sense of being able to have a production system that at the same time are pursuing two goals. One is to, let's say, be more friendly to the human workers, and at the same time to achieve the performance of the production system. In this sense, Industry 5.0 is building upon what we already had. In terms of adaptability, okay, adaptability is intrinsic in human beings. All the characteristics that we want to see in terms of creativeness, intuition, this is the big part of the value that human operators can bring to our manufacturing system, and we don't want to lose that. On the other hand, we are seeing the introduction of more and more enabling technologies that now are making automation system become even adaptable. One of these aspects, for sure, one of these enablers is collaborative robots, which has surged during the last decade. When we started to talk about this concept, we wanted to set a few statements that could keep us on track every time. So I will go rapidly through them. So the first thing you want to have in order to achieve this human-machine collaboration is to set goals. So you need to have clear in your mind, even if you're taking a strategic decision, an operational decision, that you're looking to improve worker well-being and at the same time to keep process performances in the range. One other aspect of the system is that you need to have continuous monitoring of the status of not only machines, you need to have human digital twins. This is an announcement that we need to have at the factory digitization that we have as of now. You need to make also, to keep humans in the loop, you need to have decision systems that are explainable to humans, especially when we're talking about artificial intelligence systems. Things can become very chaotic, and we need to keep people aware of the environment they are operating in, even though it's not, it may operate and have behaviors that change over time. The more we can do is to also include them in human decision systems that at the same time take the creativity, intuition of users and put it together with the solidity, soundness of AI decision makers. Obviously, we need to have underlying flexible and configurable production system. Otherwise, you are very flexible in your brain, but not in your arms and legs. And finally, you need to have continuous improvement of what you do, assess what the solution are bringing, and possibly change that. And here I'm going a step backward with respect with Kit for SME. This is IFRMS phase 3. We did an experiment in which we started working on this kind of adaptive mutualism in a company in Italy that is doing injection molding systems. And here you see, this is the process quite shortly. It's a very short set of operation that are downstream an injection molding machine. And you see there are technological constraints based on temperature, based on insertion inside this piece of magnets that have opposite polarity one another. And there is a very fast piece of the operation. This is the system that we together. And you see there are, let's say, elements for detecting the status of the system, like vision system. You will see in the video that we also have wearable devices for getting data from the human and to communicate with him. We have communication system through a lighting system here, and we have AI applications running in the background that you will see in a few moments. We were able, by the way, to close this experiment right before the next started in 2019, so you will not see massive impact, basically. One of the elements here that is affecting the human is that you have a very fast pace. Every 55 seconds, you have a new piece that is produced, and there are some operations that need to be performed in this time frame downstream to the injection molding. All this was done manually before we entered the audience. Obviously, this meant a very high cognitive burden for the operator and physical for the operator. So we introduced a cobalt in order to not just replace this operation, but be able to exchange these operations with not all of the operations could be, let's say, automatized with the cobalt, like this screwing operation and the magnet insertion is required too much dexterity in order to be done by the cobalt. So you see how also the complementary business skills and capabilities are helpful to achieve the operation. From now on, you see that all operations can be carried out on the left side of the operator. This is the quality check, and on the right side, here you see after quality check, there is a green operator, again, all the operator. And we set up a system that is reconfigurable based on work status, like mental stress that we were working with, physical stress, but also the process parameters like quality, productivity, and so forth. This is how the operator could connect to the system and start producing data through the wearable devices as well. Our machine learning system were a fatigue value, so that the fatigue level of the upper left and the stress level out of a lot of...
Andrea, please, sorry, lower a bit the volume.
Yes.
Because sure. It's a bit too high.
I can even
and pay attention a bit to the clock, please.
Okay,
Thanks.
sorry. Now the volume is off. And you see every time there is a lighting system that is the operator what is the next action that is supposed to do. So this kind of collaboration is very intense because they are not only occupying the same space, but they're also operating on the same task. And as I said before, this was meant to achieve improvements on the worker side, and at the same time, improvements in terms of the production parameters. So what are we doing now in the Kit for SME project? We are trying to transform this approach into a platform that can offer AI solutions, packages of AI solutions to small and medium enterprises. And how do we do that? First of all, in order to give customized and up to the scope solutions to our SMEs, we diagnose their needs. We have an adaptive questionnaire based on an artificial intelligence solution that is able to detect the manufacturing issues that they see underlying their production system. Based on that, out of our marketplace, we are able to compose full packages of AI solutions, so meaning sensors, meaning data collection system, and AI application that can make sense of this solution, which is our next step. Once the solution is deployed, we start understanding what is happening in the shop floor based on the artificial intelligence solutions that the company has implemented. And based on that, we can offer a configuration of a single word cell or even the entire production line. Last but not the least, we need to evolve the system to give to the workers that are operating into it the right skills to be able to interact with the new technologies that are introduced. So that is why we also have a personalized training and upskilling path that are trying to fill the gap between what the operators can do, what the new technologies require, what the aspirations of these people are in terms also of their career development. And I close my presentation with some kind of promotion. We have open calls that are still open until the 15th of December. We are funding now providers of AI solutions for SMEs in the manufacturing domain with a TRL of 5 or above, and we're still gathering applications. So in case you're interested, there's still a little bit of time to join us. Thank you, and I hope I could introduce some of the elements of this human-machine collaboration.
Thank you very much, Andrea. And now let's go quickly to the second presentation. Alice is back again with the level up project. Please share the screen and the floor is yours.
Will it work now? Okay. Thank you very much. I will present the EU Horizon 2020 project Level Up. It's protocols and strategies for extending the useful life of major capital investments in large industrial equipment. Do you see it's going on? So the next slide. Can you see it?
Yes, still in the edit mode, not in presentation. So I'm not sure you are actually browsing to the next one.
Okay, so let me try again. Okay, so I went now to the next slide. Is it okay? Can you see it?
Unfortunately not. I still see the edit. Okay. Yes, now I see the second slide. Still in edit, but it works if you are fine with you.
Okay. Okay, I will go like that because I'm not sure why it's not going further.
Okay.
So yeah, it's as I said, it's actually it's the project that basically aims to use the old equipment. So everybody knows that when companies buy equipment, is usually not only for 5 years, it's usually for 15, 20 years and so on. So it's very expensive for the companies that would buy equipment every 10 years that is up to the level of the current, I would say, Industry 4.0 standards. So this project aims basically to offer scalable platform to be covering the overall life cycle, ranging from the digital twin setup, modernization actions, to diagnose and predict the operation, physical assets, to the refurbishment and the remanufacturing activities towards end of life according to Industry 4.0. It will basically implement new hardware and new software components to the older production lines, to older equipment, and level up them, so raise them to the level of Industry 4.0. So this way, the companies will protect their investments and will help them to be much more effective than they have been in previous years. So what we have done, I would say at this point, we're working on a case study, so demo case with the company Isocon, and we providing them with the knowledge to basically upgrade their extrusion line seats for the caravan seats for the moving homes, to upgrade them to the level of the Industry 4.0. So currently they have quite old, a 15-year-old production line. It's not that old that you would say it's very old, so it's not ancient, it's quite, I would say, modern, but they have very, very little monitoring facilities, very little, how would say, instant operation mode of controlling the whole production line. You can see this, it's working 24 hours, 7 days per week, all the time. And it's really one of the key of their production. So they were very high interest there to upgrade this line to the new standards. So at this point, they have very limited possibility of machine status monitoring, no connectivity, old PLCs, no remote access, and so on. They had lower productivity. They had quite a lot of interruptions and inspections and repairs and so on. There's no process visibility. There's several hours basically to set up each time the new process. There were quite high environmental impact. There were water spills, no dust collection, and so on. It was predetermined maintenance. It's not on needed basis, but it was on weekends, no monitoring functions, no forecast, limited accuracy, no direct dimension measurement, bad thermal stability, and so on. And there was, of course, extrusion die failures. It happens on monthly basis, and of course, there's expensive repairs. And of course, when they do the repairs, the whole line is down. So what we want to do basically is make online machining, state monitoring with data transfer and processing on higher level, remote access to machine control systems, additional functions like moving extrusion table positioning, better process visibility, easy sensor installation, increased accuracy and productivity, vision and laser profile measurement of plastic profiles for better accuracy and improved productivity. We want to have improved thermal stability. We want to have predictive maintenance and preventive maintenance, basically forecasting when there will be failure and repair the line before the failure occurs. And of course, this is a must today. We want to have lower impact, environmental impact of the company. So what we have done, we have basically set up for each of the systems, for extrusion system, for mold and die system, heat and cool system, extrusion material, feeding system, cutting system. Basically, we want to connect them into one working cell, one factory, have a server and UPC UA server that controls everything. Then we have a middleware, so software that is monitoring. And at the end, we have a system that basically monitors the whole production system from the input material to the output products. As you can see, we have installed sensorics, we have installed data acquisition, we have installed temperature pressures, new PLCs, and so on to help them better data acquisitions. We have installed vision system, we have installed laser system, we have connected, and we have real-time online monitoring of the system. We have started to measure a parameter evaluation of the dies, of what are they doing, what is currently going on with them, and we have basically laser cladding and die repair of the dies immediately when it's needed, not predetermined and scheduled, let's say once a week.
Please, Alex,
and at the end, of course, we have achieved 5.
The time. Sorry to interrupt you.
Yeah,
Just
I'm
please
already,
try to squeeze a bit because we are running a bit out of time, and we still have Oscar to present. Thanks.
Yeah. So as you can see, we have installed quite new electronic architecture, PLCs, monitoring systems that basically wants to and will help them to monitor the process very effectively, to really shorten the cycle times, to shorten the repair costs, to decrease the costs, energy consumption, and also decrease really substantially the environmental impact. So at the end of the day, there's still some things that we have done, but at the end of the project, the whole line will be, even with old machines, will be working to the standards of the Industry 4.0, with, I would say, minimum investments needed for upgrade. So if there be any questions, of course, I would be gladly to answer. Okay. And thank you for your attention.
Thank you very much. We will monitor the chat in case of questions, but unfortunately, as I said, we are a bit already out of time. I invite Oscar to join us now and to start sharing the screen. And sorry for being a bit late with your presentation. The floor is yours.
No problem, Davide, and thank you very much for the opportunity. So I will try to make my best to make sure that I don't go over the 10 minutes, and I introduce you to the work that we have been performing in the quality project. This is a project that is basically aiming at the data-driven and AI power transformation with a focus on zero defect manufacturing. It is a very large project. 45 partners from 13 countries are taking part, and you can see that the diversity of technology providers and manufacturing providers is quite wide. What is the focus of the initiative? Basically, it is trying to figure out how autonomous factories can support the operation of zero defect manufacturing. We have to realize that there is a change in the way that we are designing, and we are evolving our factories, trying to move up the piece of business, lowering every time the operational cost, keeping speed, quality, and other aspects of operations always in optimal terms. And for this, we have to come up with new zero defect manufacturing strategies that are comprehensive and use data across the full life cycle. In the quality project, what we are trying to understand and to figure out is which are the new ways and the optimum ways in which human informations and machines have to interact with the aim of implementing new control loops. I think Thomas was showing some inspirational figure that we have adopted in the project. We have evolved and we have adapted, but it is important to understand that this data has to be used for two purposes: to understand and to plan what the things have to be performed in the factory, but at the same time we use data to make sure that we are able to achieve the things that we have already planned. And this means that we can increasingly make use of more sophisticated ways of using data in our factories. And this is what we are showing, that we go from very initial IoT systems up to the autonomous operations of AI-driven systems. And this implies that we have to coexist and operate two types of intelligence. Intelligence in the automation level, very much focused on the manufacturing capabilities, and artificial intelligence that is very much connected to the platform itself. So we have to move from today's systems, where we have significant latencies since the time that we detect an event and the time that we are able to respond and establish and operate a countermeasure. what we called this 0x manufacturing, that is the essence of the smart rapid response and all the digital technologies that we are bringing together in quality, is actually focused on this reduction in the response. It's not just a matter of speed, it's a matter of intelligence. And this combination of speed and intelligence is what can bring this sustainability, autonomy, circularity aspects. From the vision of 0x manufacturing, what we are bringing together in the quality project is the fact that if we master the value of zero at every phase of the life cycle in our factory operation, we will be able to balance properly sustainability, human-centric, and productivity aspects. And this means that with a 0x approach, when we are responding to one of the many waves that will disrupt our operations, recession, energy, supply chains, COVID, climate change, we will be doing this without compromising our technological future. And this implies that we have to align and harmonize a number of events and assets. And this is what the quality project is actually doing, is bringing together, integrating in an open and smart way many different elements that all the different solutions need to put in place. This may seem impossible, but how we have made it possible? Basically, putting together three main drivers. The first one is data quality, the second one is ensuring excellence in data operations, and the third one is to think in terms of data sharing by design. But this implies that we have to unify the way in which we manage big data pipelines, big data spaces, and the way in which we integrate services. So it is not just about sharing data, it's how we share data. So in the vision of quality, we have a factory that we would like to be able to sense, think, learn, act, and adapt. And in order to realize this, we need to have common approaches, common reference models that have to work together. And we need to break the silos, connect the data endpoints, and integrate digital services. And we do this by aligning three specific reference models. A reference model that is based on the ISO 25447 reference model for big data, the DIN Spec 27070 that deals with data sovereignty and trusted information data gateways, and our 0x manufacturing digital service integration model. This model is actually coming and being supported by the work performed along many years by many different projects. And what is important is to realize that this model, in order to build the specific solutions we have to support, actually brings together intelligence across the different factories and life cycle. So from the smart functions to different types of reasoning that need to be reactive, deliberative, and at the end of the day, support this smart rapid response at the human-centric level of optimization. The 0x Manufacturing Excellence Project has put together 15 smart rapid response pilots. And those pilots fulfill specific needs across the life cycle of quality management. And actually what we are doing in the project is to make sure that we can manage quality across the full life cycle. So that means that we can work on the quality of the design, the material quality, the components and the parts quality, the logistic, the assembly, and the final product and service delivery. With a holistic approach, but with a unified and shared common model, is how we can actually deliver this digital integration of many diverse digital enablers into unique solutions that can be shared, replicated, and scaled up. This means that through these pilots, we have been able to develop these 0x quality products. And to go beyond the pilots themselves and to make sure that we are able to live beyond the end of the project, Quality has set up the Digital Factory Alliance. The Digital Factory Alliance is basically an alliance that supports data-driven intelligence, digital integrations to make sure that efficiency, sustainability, and resilience can actually be balanced. Because the Digital Factory Alliance is actually supporting reference model, qualification schemes, to make sure that performance is always connected with intelligence and speed in terms of the digital platforms that we can bring together. The Digital Factory Alliance mission is basically to put together an international trusted community of digital factories stakeholders that are ready to share knowledge and are prepared for industrial collaboration to master digital integration, data-driven intelligence, and ensuring that their products and their customers can actually realize this smart, rapid response. This has been initiated by three main companies that are core partners of key data-driven initiatives that have been mentioned already during the session today, Gaia X and IDSA. And a number of lighthouse factories that are willing to showcase how these type of technologies can really change and improve performance and impact of their operations. We are starting to set up a network of collaborators. The first collaborator is the World Economic Forum, but we are obviously a very young alliance, and we are open to collaboration with communities like BBVA and the manufacturing community. Our main focus is really to complement existing initiatives to make sure that we can open market opportunities for digital technologies that can support a smart, rapid response for 0x manufacturing. And this means that we have to put together a community, that you can become part of this community. You can search for knowledge, you can search for products, you can search for services, and you can do this in a continuous innovation and rapid ecosystem. An ecosystem that brings together flagship initiatives, body of knowledge, innovation campus, and business networks. So we can go really down to the market opportunity level. And just to conclude my presentation, I would like you already to join some of our open dialogues. We are not a closed community. Obviously, we have activities for our members in the Alliance, but we are open to participation and collaboration with the manufacturing and the data community. And here I would like to share with you the possibility to take part in our open dialogues. Please feel free to register. They are free of charge. Download our for industry report, where you can see in detail what the companies in the Digital Factory Alliance have been able to achieve in terms of competitiveness with the use of the common reference model. And if you want to follow us, simply register to our newsletter. Thank you very much, and enjoy the rest of the event.
Thank you very much, Oscar. And also thanks to all the speakers that we have in this second part. Just let me wrap up that. I guess you can see my slide now. And given said that, I also pass to thank everyone for your attention. First of all our speakers, but all the attendees that we had today. Given said that, I invite you, I invite you all to follow the activities that the Smart Manufacturing Industry Group is doing in BDVA. You can do that from the website, but even better, if you can join us, you can join the association, and then you can take directly part of the work that we are doing there. So it's time to close. I say goodbye to you all, and have a nice weekend.
Thank you. Goodbye.
Thank you.
Bye-bye.
Bye.
Thank you.
Bye-bye.
Goodbye.
Thank you. Good.